All right, folks, in this video, we are going to continue our work with polynomial long division. Today, we are going to do some problems that don't divide evenly, so there will be remainders in the problems you're doing today. And then we're also going to look at how to do division problems where maybe terms are missing. So let's go ahead and get started. For our first problem, we are going to do x to the third power. Oh no, excuse me, that's wrong. X to the second power is what I want. Well, I don't know why it did that. Let's start over again. All right, so here we go. We are going to do x to the second power plus 3x minus 43. And we are going to divide that by x plus 8. All right, so for this problem, again, just like we did earlier in the week, we are going to start by rewriting this as a long division problem. So on the inside, we're going to have x squared plus 3x minus 43. And on the outside, we're going to have x plus 8. Okay, now remember how this goes. You are going to start out by asking this question. How many times will this first term of x go into this first term of x squared? So how many times will x go into x squared? And remember that when you ask that question, what you're really asking is, what would I have to multiply times x in order to get x squared as the result? So that's what we're asking, is x multiplied by what would give us x squared as the answer. And we know that the answer for that is x. So x will go into x squared x times. And we're going to put that right here above our 3x. All right, now, once we put this up here, the next step is to multiply this x by x plus 8. So we're going to do x times x, which is x squared. We put that underneath x squared. And then we also do x times positive 8. That's a positive 8x, and we'll put that right here underneath the 3x. So how many times does x go into x squared? The answer is x times. We put that up top, and then we do x times x plus 8 to get x squared plus 8 down here at the bottom. Now, here comes what I believe is the most dangerous step in any division problem, and that is the subtraction step. Because what you have got to remember, and I'm going to put parentheses here again to remind us, is that you are subtracting all of this. So you are subtracting the x squared, and you are subtracting the positive 8x. So you are subtracting both of those. So keep that in mind as you do this step. So you are doing x squared minus x squared. Now that's going to be 0. So these two are going to cancel each other out. Now, on the second part, you're doing a positive 3x minus a positive 8x. So you're doing 3 minus 8. And we know, of course, that that is a negative 5, so I'm going to put a negative 5x right here. So remember, when you subtract, you're subtracting both of these terms. You're subtracting the x squared and you're subtracting the 8x. That negative distributes to both of those. All right, now that we've subtracted, we bring down our next term, which is minus 43. And then we know, of course, that the process starts all over again. So now we are asking the question, how many times will x go into negative 5x? So x times what will give us negative 5x? Well, the answer for that is negative 5. So x will go into negative 5x negative 5 times. So we'll put that up at the top. Now that negative 5 is going to get multiplied by this x plus 8. So we'll do negative 5 times x, which is negative 5x. And then negative 5 times positive 8 is a negative 40. And again, we're back again to that most dangerous step, because now we're going to subtract all of this. So keep in mind that you are subtracting negative 5x and you are subtracting a negative 40. So keep that in mind, that you're subtracting both of those terms. So we're doing negative 5x minus negative 5x. Those two are going to cancel each other out. And then on the second part, be super careful, because this would be so easy to miss. You are doing a negative 43 minus a negative 40. And we know when we do minus a negative 40, that's going to change to plus 40. So you're doing negative 43 plus 40, which would be negative 3. Now, this is where this problem is different than the ones that we looked at earlier in the week, because earlier in the week, this last subtraction answer was always a 0. You all will remember in elementary school that you did division with remainders, and that's what we have here. I know that I'm finished with my division problem because I don't have another term to bring down. So that means that at this point I'm finished. So I have my answer, x squared plus 3x minus 43. Divided by x plus 8 is going to be x minus 5 with a remainder of negative 3. Now you may recall writing your answers in a way that was similar to this when you were in elementary school. Now there's another way to write this answer, and it's actually the one that I prefer. So this is the one that I'll want to see on work that you turn in. So instead of x minus 5 with a remainder of negative 3, we're going to write this as x minus 5. And then because this remainder is negative, I'm going to put a minus. So let's be clear here. I'm putting this minus because this remainder is negative. And then I'm going to put that remainder of 3 over my divisor, which is x plus 8. So I'm going to put x plus 8 underneath that 3. And I'm doing that for this reason. I'm letting anybody who looks at this know that that remainder of negative 3 still needed to be divided by the x plus 8, but that I wasn't able to do that. So that's what this is saying, is that remainder of negative 3 still needs to be divided by that divisor of x plus 8. So this is the way that I would prefer to see that answer written. So notice this is the exact same process that we were doing on Tuesday, but this time you won't always on that last subtraction get an answer of 0. There will be remainders in your answers that you're looking at today. All right, so let's look at one more of those. Let's do 2n squared minus 16n plus 19 divided by n minus 7. So again here, we'll start out by rewriting this as a long division problem. So 2n squared minus 16n plus 19, and we are dividing that by n minus 7. All right, so we begin with how many times will n go into 2n squared? So what would I have to multiply times n to get 2n squared as the answer? Well, n times 2n would give me 2n squared, so n will go into 2n squared 2n times. And I put that up top, right above that negative 17n. All right, now time to multiply. So we're going to do 2n times n, which is 2n squared, And we're going to do 2n times negative 7, which is a negative 14n. Time to subtract. And remember, you are subtracting 2n squared and subtracting negative 14n. So be careful with this. First part's pretty easy. 2n squared minus 2n squared. These will cancel each other out. Be careful on this second part because you are doing a negative 16n minus a negative 14n. So it's minus a negative, which we know will change to plus. So we have a negative 16n plus 14n. That is a negative 2n. Now we bring down our very next term of plus 19. And then we're ready to go again. So this time around, we're going to ask how many times will n go into negative 2n. So in other words, what would I have to multiply times this n to get him to become negative 2n? We would have to multiply n times negative 2 to get that to become a negative 2n. All right, so now let's multiply. We're going to do a negative 2 times n. That will give us a negative 2n. And then we'll also do a negative 2 times a negative 7, which will give us a positive 14. No more terms to bring down, so once we subtract, this will be done. So we're going to subtract all of this. So you are subtracting negative 2n and subtracting positive 14. So first up, negative 2n minus negative 2n cancels out. And then you're doing 19 minus 14, which is 5. So we get a remainder of 5. So the answer for this division problem is 2n minus 2 with a remainder of positive 5. I'm going to want you to write that as 2n minus 2. And since our remainder is a positive number, we are going to put plus. And then we're going to put 5 over n minus 7. So notice on the bottom of the fraction, I put this divisor of n minus 7. So this would be my answer. All right, so that gets us started today with a couple of examples that have remainders. On these next couple of problems, we're going to talk about problems where there are terms missing. So let me show you what I mean by that. And then every division problem that you do on today's assignment, you need to look for this first. So this needs to be what you do on every problem. All right, so here we go. On this third problem, we are going to do k to the third power minus 17k plus 32. And we're going to divide that by k plus 5. Now, here's what I mean by missing powers. Look in your first set of parentheses. This thing starts out with k to the third power. All right, then we have minus 17k. Now when I see this k, I know that that's being raised to the first power. And then I have plus 32. So I have k to the third. Then it skips k to the second, goes to k to the first, and then 32. So I have skipped from a power of 3 to a power of 1. So right here, I have skipped k to the second power. That is a missing power. Now, when that happens, so look at this and see what your highest exponent is. And you don't want to skip any exponents as you go through the rest of that problem. So here's what we'll do. When we change this thing over to a long division problem, we're going to put that k to the third power down. But then where we've skipped k to the second power, we're going to insert a placeholder for that. And you're going to put 0 k to the second right there. That's really just a 0, so you haven't added anything to the problem that will change it. You're just making it look different. So if you see that your problem has skipped an exponent, then you're going to need to put a 0 placeholder in the problem for that. And then we'll continue on with our minus 17k to the first, and then our plus 32. So always check your problems from here on out to see if they've skipped a power. So start at the beginning, and if it starts with a third power, then it should go 3, 2, 1. So kind of watch for that. All right, now we're going to divide that by k plus 5. All right, so now from this point forward, it's just like the others. We're going to ask how many times will k go into k to the third. So what would I have to multiply times this k to get it to become k to the third? And the answer is I would have to multiply it by k squared. And notice I'm putting that above that k squared that I added to the problem. So that's why you need that placeholder. Because when you get k squared, you need to be able to put it above k squared. All right, so now we're going to multiply k squared times k becomes k to the third. And then k squared times positive 5 is a positive 5k squared. So notice again here how that placeholder helps me, because it lets these things line up the way that they should. All right, so now we're going to do a little subtracting. And remember, you are subtracting both of those terms. So you're doing k to the third minus k to the third. Zero's out. And then you're doing 0k squared minus 5k squared. 0 minus 5 is a negative 5. So we get a negative 5k squared. So now we're going to bring down that very next term of negative 17k. And then we're going to go through that dividing process again. So we're going to see how many times k will go into negative 5k squared. So what would I have to multiply times k in order to get negative 5k squared? And the answer is I would have to multiply it by negative 5k. Notice that it lines up above the k term in the problem. All right, so now we're going to do negative 5k times k, which will give us negative 5k squared. And then negative 5k times 5 is negative 25k. All right, subtraction time. And don't forget, you're subtracting both terms. Boy, could my lines get any more crooked. All right, so negative 5k squared minus negative 5k squared. Remember, this minus and negative will turn into a plus. So these will cancel each other out. On this next part, be careful because you're doing a negative 17k minus negative 25k. So again, minus and negative will change into plus. So you're doing negative 17 plus 25. And that is 8k. Now normally at this point we're done, but notice we have another term to bring down. So we bring down our plus 32. That's the last term to bring down, so this should be our last trip through the division process. So how many times will k go into 8k? So what would I multiply times a k in order to get it to become an 8k? And the answer is a positive 8. 8 times k, 8k. And 8 times 5 is positive 40. And let's subtract one last time. $8k minus 8k, 32 minus 40. Would be a negative 8. So my answer is going to be k squared. Oh, let me try again. K squared minus 5k plus 8. And my remainder is negative 8, so I'm going to put minus 8 over k plus 5. So hopefully you see what I mean by the missing powers. This skips from k to the third straight to k to the first. So we're going to have to put a placeholder in there for k squared because it skipped that power. That's what we mean by missing powers. All right, so we're going to look at one last one. All right, on this one, we're going to do 8x to the fourth minus 64x to the third plus 3x minus 28 and we're going to divide that by x minus 8. All right, now as we convert this thing to a long division problem, let's see if it skips any powers. Let's see if there are any missing powers. All right, we start out with x to the fourth. Then it goes to x to the third. Then it goes to x to the first. So notice 4, 3, 1. We have skipped right in here x to the second. So we're going to have to add a placeholder for that. So it's 4, 3, 2, 1, and then we have our minus 28, which doesn't have the variable x. So we need a placeholder for x squared because this polynomial skipped x to the second power. All right, so in here we're going to put 8x to the fourth minus 64x to the third plus, and now it's time for our placeholder, we're going to put 0x squared plus 3x minus 28. And all of that is going to get divided by x minus 8. So I wanted you to see a couple of these so you would know how to identify what was missing and put those placeholders in. So how many times will x go into 8x to the fourth? So again, in other words, what would I have to multiply times this x to get it to become this 8x to the fourth? And the answer is I would have to multiply by 8x to the third. And notice where that is. That's right above the x to the third term. All right, multiply 8x to the third times x. That will give you 8x to the fourth. And then 8x to the third times negative 8 will give you a negative 64x to the third. Now on this one, when we do 8x to the fourth minus 8x to the fourth, both of these will go away. And here's something kind of interesting. I don't think we've seen this before. We've got a negative 64x to the third minus a negative 64x to the third. Those are going to cancel out as well. So you have nothing over here. So you are going to bring down 0x squared. And then I would also go ahead, if I were you, and bring down this plus 3x. So this is a little different. We haven't seen this before. All right, so now we're going to ask how many times will x go into 0x squared. So what would we have to multiply times x in order to get 0x squared? And the answer is we would have to multiply by 0x. Now I'm going to scoot over here to put that because I want it to be above the x term in my problem. All right, so 0x times x would be 0x squared. And 0x times negative 8 would be 0x. Then we subtract. 0 minus 0, not too exciting there. 3 minus 0. And then we bring down our minus 28. And this will be our last trip through the division process. So how many times will x go into 3x? So in other words, what would I multiply times an x to get it to become a 3x? And the answer is positive 3. So we do 3 times x and get 3x. And we also do 3 times negative 8 and get negative 24. And we subtract. 3x minus 3x is 0. Negative 28 minus negative 24, that'll change into plus 24. So we get negative 4 as our remainder. Now, when you come over here to write your answer, this plus 0x you can actually leave out of the answer because 0 times x is a 0. So this answer would be 8x to the third plus 3. And then with my remainder, I'm going to put minus because it's negative. And then it'll be 4 over x minus 8. All right, so most of the problems, as a matter of fact, I think all of the problems you're going to do today will have a remainder at the end. It won't be 0 like it was earlier in the week. And then please watch out when you're looking at your problems for those missing powers. So like this one started with x to the fourth, then it had x to the third, then it skipped over x squared and went straight for x to the first. Make sure you insert those placeholders for any powers that might be missing from your problem. If you have questions about long division or about anything in this video, then please contact me and let me know. Tomorrow we will be learning a second division method called synthetic division, which I think you'll actually find to be a little easier than long division. So you can look forward to that. In the meantime, any questions, be sure and let me know.